Hello, you are welcome to my channel today. In today's video, I want to solve a nice challenge which read 2 to the power of y minus 2 to the power of x is equal 4, y minus x is equals to, question that says x and y is equals to what? So we are looking for the value of x and y in this challenge. So simply say solution. Then write 2 to the power of y minus 2 to the power of x equal 4. I call this one equation 1. Then write again then write our y minus x is equal to, call this one equation 2. Okay, after having that, the next thing we are going to do, we are going to make x to be the subject of formula in equation 2. So we are going to say x is equals to, by the time we make x to be the subject for formula, becomes y minus 2. By the time we make x to be the subject formula in equation 2, your x now equals to y minus 2. So this, we can call this equation 3. So we can say putting equation 3 into equation 1. Remember, our equation 1 is 2 to the power of y minus 2 to the power of x equal 4. So we are going to put x in the place of x. We are going to put y minus 2. So we are going to have 2 to the power of y minus 2, open bracket, y minus 2, close bracket, is equal to 4. Okay, having done this, we can simply write. So this is our new equation. So we are now having 2 to the power of y minus 2 to the power of y minus 2 equals to 4. Applying a principle from indices, we say if we are having a to the power of m minus n is also equals to a to the power of m. It's also equals to a to the power of m multiplied with a to the power of minus n, from the principle of indices, right? Okay, obeying that rules, so we are going to have, at this point, we are having 2 to the power of y minus 2 to the power of what? Y times 2 to the power of minus 2 is equals to 4. Okay, having done that, so we can simply, at this junction, applying the same rules from indices again, which says if we're having a to the power of minus n is also equals to 1 all over a to the power of what? N. So at this junction, applying this rule here, we are going to have 2 to the power of y minus 2 to the power of y times 1 all over 2 to the power of 2. Okay, since this is our new equation, which says 2 to the power of y minus 2 to the power of y times 1 over 4 is equals to 4. So the next thing we are going to do, we are going to look on how we can remove this denominator here. So what are we simply going to do? We are going to multiply both sides with 4. So if we multiply both sides with 4, we are going to have 4 multiply with 2 to the power of y minus, so if we multiply here with 4, this 4 will cancel off this, so we are left with 2 to the power of what? Of y times 1 is equals to 4 times 4. Okay, so we are going to have 4 times 2 to the power of y minus 2 to the power of y is equals to 16. So having done this, you can see that at this junction, we are having 2 to the power of y common. So you can simply say 2 to the power of y, factoring it at 4 minus 1, close bracket, is equals to 16. So we are left with 2 to the power of y, open bracket, 3 is equals to 16. Okay, having done all this, we can now divide both sides by 3. So we are going to have 2 to the power of y is equals to 16 all over 3. which implies our 2 to the power of y is equals to 16 all over 3. Okay. Having done this, then what then is the next step? In order for me to get our y, I can multiply this y with, I can multiply both sides with the natural log, I can multiply both sides with the natural log, or I can multiply both sides with the log of base 2. But in order for me to remove this 2, I can multiply both sides with the log of base 2. So I can say log 2 to the power of y base 2 is equals to log 16 all over 3 base 2. So this is exactly what I'm trying to say. Log 2 to the power of y base 2 is equals to log 16 all over 3 base what? Base 2. So having done this, so what are we simply going to do? From the principle of indices, which says if we are having log a to the power of b is also equals to b log a. Let me just put a base in order in base B. Let me say in base C. So applying this principle at this junction, we are going to have y log 2 to base 2 is equals to log 16 divided by 3 to base 2. So you can see this and this are now in the same form. And from logarithm again, which says we are having log a to base a is equals to 1. From the principle of logarithm, log a to base a is equals to 1. So at this junction, this and this will give us 1. So we are having 1 multiply with, y multiply with 1 is equals to log 16 over 3 to base 2, which implies your y is equals to log 16 over 3 to base 2. Okay, since we've gotten y to be equals to log 16 over 3 to base 2, then our x is equals to y minus 2 from our third equation. So what are we simply going to do at this junction? So in the place of y, we are going to plug in log 16 over 3 to base 2. So we are going to have our x is equals to log 16 over 3 to base 2 minus 2. Okay, having done that, I remember we said we can simply transform this man by saying our x is also equals to log 16 over 3 to base 2 minus 2 times 1, right? Because if we say 2 times 1 is going to give us what? 2. So any number multiplied with 1 is the number itself. So we are going to say x equals to log 16 over 3 to base 2 minus 2. I recall we said we can say, if we say log 2 to base 2 is also equals to 1. So at this point we are going to put log 2 to base 2 in the place of this what? Of this 1. So I'm going to say our x is equals to log 16 over 3 minus 2 times log 2 to 2. Okay, having done this, we are now having our x is equals to log 16 over 3 to base 2 minus, if this one is coming to this side, we are going to have log 2 to the power of 2 to base 2, because if we are having 2 log 2 to base 2 from principle of indices, we can simply write this to be log, this one will be coming to this top, so will become power to base 2. So this is exactly what we applied here. So we are going to have our x is equals to log to 16 over 3 minus log 4 to base 2. 4 to base 2. So for more emphasis on this, our s can be therefore x is equals to log. So since log base 2 is common, we can factor it at log base 2 open bracket 16 over 3 divided by 4. And by the time we do that, our x is equals to log base 2 open bracket 16 over 3 times 4. So by the time we cancel off, so our x is equals to log base 2 open bracket 4 over 3. So this is your value for y, and recall for x, and recall that our y is equals to log base 2 16 over 3. So this is for our y and this is for our s. So if you find this video interesting, you can click on the subscription button and hit up the notification bell so that you get notified anytime we release videos on maths. And also don't forget to hit the thumbs up. Bye bye for now.